Hello, is the audio clear? I hope now it's clear. Could you please confirm, is it clear or not? So we can start. I'm sorry for the delay. Yeah, okay, thank you. Sachin, thank you very much. So where were we? We were discussing, I'm sorry. So where were we? Yesterday we discussed first law of thermodynamics, but hi Pavan, Sachin, Sudarshan, good evening and welcome. Okay, so yesterday we were discussing first law of thermodynamics, but our focus was on closed systems, right? We have done one question for open system. Today our focus is on open system, and in open system when we talk about, there is steady flow energy equation and there is unsteady flow energy equation. This is our focus for today. Okay, so let's start, right? Let's start very quickly. So just very quickly, my introduction. I have around 4+ years of teaching experience. I have done MTech. I have done MTech from IIT Kharagpur. I have done MSc from Politecnico di Milano. Do not get confused with MSc. It is MSc, MS, M Engineering, whatever you want to call it. I have some industry experience, some research experience, and also I have published some research publications, international and national. And this is what we are doing right now. And I will be taking other subjects as well. Okay. So let's very quickly move to the question that I gave you yesterday. Sachin, I think you were there, and if the people are here who were there yesterday, could you please tell me, did you solve it? What was the answer? Did anyone try this question so that we can move ahead? Because today we have to solve many questions for open system. Did anyone try this? Very quickly, can you please tell me? What is the answer for this? Which statements are true? A not correct. Yes, very nice, Bhavya. Is B, C and D are correct or not? Okay, you did not solve it, or you were not able to solve it. Sachin, did you try it, or okay, rest all are correct? Yes. Sachin, did you try it, or you could not try it? Yeah, that is correct. Rest all are correct. B, C, D and correct. B, C, D, they are all correct. This is 80 kilojoule. When you check, it is 80 kilojoule. Okay, minus is not there. Okay. So, okay, so you were not able to, Sachin, were you not able to solve it? What was the issue? It's very simple. It's fairly simple question. Very simple question. Work you have to find out. What is work here? P V2 minus V1. V2 and V1 is given. Pressure is also given 2 bar. Right? So work done you can find out. Internal energy is given. You can find out heat transfer. Very simple. I don't think there should be any. If you are solving with me, I don't think this question should be difficult for you. Sachin, can we move ahead? Can you try this again one more time? What is the work done for this? P1, I'm sorry, P2 V2 minus P3 V3 upon N minus 1. That is the work done for 2 to 3. Okay, Sachin, we will move ahead because I have to solve some open system which are fairly, questions, because they are fairly long. So we have to focus that as well. But that is very easy question. Okay, so we are moving ahead. Okay, this is the first question. Okay, this is the first question. A gas flows steadily through a rotary compressor. So they are saying it is a steady flow. The gas enters the compressor at a temperature of 16 degrees Celsius. So what do we have? We have a compressor, right? We have a compressor. This is entering, this is coming out too. Okay, so a gas is entering into a compressor at temperature 16 degrees Celsius. Temperature is T in is equals to 16 degrees Celsius and pressure is 100 kilopascal. Pressure is 100 kilopascal. Okay, and enthalpy is also given at the inlet. Enthalpy is also given, right? 391. Enthalpy is 391.2 kilojoule per kg. Okay, now the gas leaves the compressor at a temperature of, so it is leaving out is equals to 245 degrees Celsius. Pressure is 0.6 megapascal. Okay, it is megapascal, not kilopascal. You have to change it into kilopascal. And enthalpy is also given. Enthalpy is 534.5 kilojoule per kg. Kilojoule per kg. There is no heat transfer. There is no heat transfer. Okay, so heat transfer Q in is equals to 0. Neither it is coming in, neither it is going out. Okay, so Q net is equals to 0. Now evaluate the external work done per unit mass. Per unit mass. So mass is 1 kg. Assuming the gas velocities at entry and exit to be negligible. That is the A part. Okay. So what do we know about this? Is a steady flow system. Okay, they are saying it is a steady flow system. What do we know about steady flow systems? If I apply energy conservation, first law of thermodynamics is what? Energy conservation, right? If I apply the first law of thermodynamics in this system, can I write energy in is equals to energy out plus energy of the system if there is any change in the system. Now it is a steady flow system. What does it mean by steady flow? That whatever mass is coming in, the same mass is going out. No mass or energy accumulation inside the system. There is neither the mass is increasing nor it is decreasing, neither the energy of system increasing. Okay, so there is no mass accumulation inside the system. Okay, inside the system there is no mass accumulation and no energy accumulation, so this becomes 0 only for steady state. In unsteady state this is not equal to 0. We will see what it means. Okay, so because in unsteady state the energy of the system, what is your system? This system, energy of system changes. Okay, so for steady state, steady flow it is 0, for unsteady it is not 0. Okay, so what is energy in, what is energy out? We all know what is steady flow energy equation. M in H in plus V in square by 2 plus GZ in plus, what is this? This is the energy that this mass has. Whatever mass is entering into the system, this much energy it has. Okay, so this is the energy which is going inside with this mass, whatever mass is going in. Okay, it is because of its temperature, it is because of its velocity, it is because of its potential difference. Okay, also if any heat we are giving to the system, we are assuming that we are giving the heat to the system as of now. Okay, Shubhadeep, Pranam, very nice, you are here again. Okay, so let's move ahead if you are here. Okay, so we are assuming that we are giving heat to the system, that's why I am taking in the inside of it. Okay, I am taking on the inside. Now what is out? Some mass is going out, right? Some mass is going out, so it is carrying some energy with it. What is that energy? Mass out, H out plus V out square by 2 plus GZ out. This is the energy that the mass that is going out is carrying with itself. Also I am assuming my system is giving out some work. I am assuming there is a net work output. My system is giving me some work. So this equation is defined assuming that I am giving heat to the system and my system is giving me work output. So work is giving, okay, work is coming out, net work output we are getting. But it is a compressor, so we know compressor is it is a work absorbing device. So if we put it like this, in the end we will get it negative. Okay, we will get it negative. Work is 143.3. very nice. Okay, so let's, I hope Sachin, are you able to solve this? And Pawan and Mondal sir, are you able to solve this? So we will quickly move ahead. I hope you got an idea. Okay, so in the first thing they are saying that this is negligible, this is also negligible, no heat transfer, this goes away. What are we left with? M in H in minus M out H out is equals to work output. Now it is a steady flow system, so what do I know? I know that mass in is equals to mass out. I know this, it's a steady flow system. I can take mass common, H in minus H out is equals to work output, and now I can say work output by mass is equals to H in minus H out. Now what is this? This is work per unit mass, external work done per unit mass. So I can show this by small w. Work output is equals to H in minus H out. H in and H out is given to me. This is H in, this is H out. When you put this, you will get minus 143 point, how much is it? Minus 143.3. very nice. Kilojoule per kg. Okay. Why is it negative? Why, Sachin? Yes, very nice. Always put the units, please. Always put the units. Okay. So why it is negative? Because in the beginning I assumed that my system is giving me work. I have taken the notations like this. So this is not work output. Work output is negative. It means it is work input. Okay. So this is when I am assuming gas velocities at entry and exit are negligible. Very quickly tell me, if I also assume entry and exit velocities, what will be the answer? We have to do some work on the device. Yes, that is why it is negative, because we assumed that my system is giving me work. And if it was positive, that means it is giving me work, but it came negative. This means I am giving that work to the system. Okay. Now very quickly write the steady flow energy equation. Steady flow energy equation. H in plus V in square by 2 plus GZ in plus Q in by mass is equals to H2 plus V H out. H out plus V out square by 2 plus GZ out plus W out by mass. I have divided everything by mass. 161, I don't think it is correct. Can you please check it one more time, Bhavya? I don't think 161 is correct. Just check one more time. Okay. So this is 0, we know. This we are assuming negligible. So work output, let me write it by small w, is equals to Hi minus H naught plus Vi square minus V naught square by 2 by 2. Now there is there is something that you need to consider here. There is something, you see this equation is derived, no, let me tell something to you, then you will figure it out, okay? So what I am saying, this equation is derived in a way that it is in joules. H is in joules, okay? H is in joules. H is in joules per kg. Velocity is in meter per second, okay? And GZ is what? Meter per second square and meter. So this is meter square second square, okay? So basically it is in terms of joule, not in kilojoule. Whenever you are putting, now you have to be very cautious when you are using this equation. When you are putting H in kilojoule, which is given to us, this is in kilojoule, right? When you are putting H in kilojoule, you have to divide this by 1000. I mean, you have to multiply it by 1000, okay? This 2, you have to multiply it by 1000. Also, this you have to divide by 1000. Then these, because what do we know? That meter square second square is equals to joule per kg. Okay, joule per kg. You can try to derive it. You can try to derive this. It can be proved, okay? So, now I think you should get the answer. How much is it? V1 is 80, V2 is 160. 152.9, absolutely correct. Sachin and Pawan, are you able to solve this? Sachin, Pawan, did you solve it? I think you made some mistake earlier, but are you able to solve it now? Pawan, yes, minus 152.9 kilojoule per kg, absolutely correct. Kilojoule per kg. Okay, so we can move ahead with the next question. Okay, this is a good question. Okay, I have shorted, I have reduced the question for you. It has 4 parts, but we are considering only 2 because that is relevant for our open system. Okay, now what is it saying? It is saying steam is entering into a 15 centimeter diameter horizontal pipe. Please consider each and every point. Each and every point is important. This is the diameter of the pipe. We have horizontal pipe and saturated vapor. Saturated vapor means, what is the dryness fraction? X is equals to 1. It is entering at 5 bar with a velocity of 10 meter per second. Okay, and it is exiting at 4.5 bar. So pressure is reduced. And a quality now at the exit quality is 0.95. At the exit quality is 0.95. So what does it mean that if I say the quality is 0.95? If I am saying quality is 0.95, what does it mean? It means that it is a mixture of vapor and liquid. Okay, vapor and liquid. And 95% is vapor. Okay, now heat is transferred to the surrounding at 300 Kelvin from the pipe surface, which is at the average temperature of 400 Kelvin. So the pipe surface is at 400 Kelvin, surrounding is at 300 Kelvin. Under the steady state operating conditions, determine exit velocity we have to determine, and the rate of heat transfer from the pipe surface we have to determine. Now, because it is a mixture, of vapor and liquid, this steam table is given. We are going to use that and we are going to find what is exit velocity and rate of heat transfer. Okay, so this is the question. Let us draw the diagram of it. We have a horizontal pipe. We have a horizontal pipe of diameter 0.15 meter. Can you tell me what is the area? Pi by 4, 0.15 square. Please calculate the area. Okay, this is the area of this pipe. Now steam is entering. Steam is entering at 5 bar. So P1 is 5 bar and velocity 1 is how much? 10 meter per second. Okay, let me check. No, that is not correct. What is that? Meter square. What is meter square? What? Okay, I'm sorry. Area is okay. That is correct, I think. Let me check the answers. 0.0177. Yes, correct. Yeah. Area is equals to 0.01, huh? 0.0177 meter square. Okay. Now the steam is coming out. Here the dryness fraction is equals to 1. It is pure steam. It is pure steam. Okay. Here the dryness fraction is 0.95. That means it is a mixture of steam and liquid. Okay. And pressure they are giving at this point is 4.5 bar. 4.5 bar. Now I need to find out V2 and I need to find out area. I'm sorry. I need to find out heat transfer. So they are saying some heat transfer is also happening. Q out is there. Q out is there. So two things I need to find out. Okay. So what do I know about steady flow? I can use the steady flow equation, right? So let me write a steady flow equation. Steady flow energy equation. What is it? M in H1 plus V1 square by 2. Always if you are putting H in kilojoule, you put here 2000 then. Okay. But I always define it according to joules. Okay. So this is a general equation. Okay. Plus GZ1 plus Q in is equals to M out H2 plus V2 square by 2 plus GZ2 plus work output. We all know this equation. There should be no doubt about it. Okay. Okay. So we know it is a horizontal pipe. Okay. It's a horizontal pipe. I can neglect this. Also what steam is just flowing. Okay. There is no work output. It is not a work producing or work absorbing device. It is just a pipe. Okay. They are saying some heat transfer is happening. They are saying some heat transfer is happening, which we need to find out. So I need to find out this. I need to find out V2 as well. So two unknown is there in this equation. Two unknown. Q, when you look, that is what? It is saying heat is transferred to surrounding at 300 Kelvin. So I know that there is some Q out. Okay. Now if it is Q out, I'll get negative. It's not an issue. How to follow your lectures in order? I was not getting your previous classes. There is a Telegram channel that you can join for the schedules, or very frequently please follow BYJU'S exam prep GATE. Okay, BYJU'S exam prep, GATE and ESC English. Just GATE and ESC, GATE, ESC and PSU. You will get. So there is a Hindi channel, English channel. You can follow both. Okay, but this is in English channel. Okay, I hope that answers your question. Or there is a you can search on Telegram. There are few channels where you usually get schedule also. Okay, so very quickly let's move on to the question. So in this equation I have two unknowns. Bhavya, I think I have answered this, right? Q in will be negative. Yes, Q in will be negative because it is Q output. Sir, how to know to neglect in SFE? Yes, I'll answer that. So what happens usually if no information is provided, for example, either they will give you velocities, either at least one velocity they will give. Okay, because there cannot be two unknowns in the same equation, either at least one velocity they will give. First of all, in thermodynamics, kinetic energy and potential energy are always neglected. Only in steady flow, for example, nozzles, diffusers, we consider velocity. This is all mostly 99% they are neglected. If no information is given in the question, you can directly neglect it. In this question, if they won't tell me this velocity, I'll directly neglect it. Okay, if they will not give me this velocity, I'll directly neglect it. Okay, but they have given me and they have asked the exit velocity. Okay, so work output, about work output, you should know that if it is a turbine, if it is a compressor, then you cannot neglect that. If it is a heat exchanger, it is a nozzle, it is a diffuser, it is a pipe, only flow is happening, so you can neglect work output. Okay, those are not work producing devices. Only turbine and compressors or pumps basically handle liquid. So that doesn't come into thermodynamics. Thermodynamics, mostly 99% we deal with gases. Okay, so we don't talk about pump in thermodynamics much, but sometimes you, like, if a question comes, but in compressors and turbine, work cannot be neglected. In nozzle, diffusers, heat exchangers, pipes, work is neglected. Okay, very quickly let's move on. We have less time and we have to solve a lot of questions. Okay, now is there any other unknown in this, or we can find out things? How can you find out M in? How can you find out M in? So M dot in, let's say M dot in is equals to rho 1 A1 V1, velocity, density, area into velocity. Okay, so can I write A1 V1 upon specific volume 1? What is specific volume 1? Specific volume here, where we have 5 bar and saturated steam. So can you tell me, yes, area into velocity upon specific volume. Can you tell me what is the value of specific volume 1, V1? Can you see this table and very quickly tell me what is this? I hope this table is clear, it's not blur. I am 0 point, yes, very nice. This is V1 is this, very nice. So you can find out M dot in, and it is a steady flow system. So M dot in is equals to M dot out as well. It is a steady flow system. Okay, now what is happening? It is a steady flow system. Okay, now, so I know this, I know this, I know this. V1 is known to me. Yes. H1, what is H1? Can you tell me what is H1? Can I calculate what is H1? H1 is here. H1 is here. M1 is equals to, I think so, 0.471. Yes, that is correct. Bhavya, M1 is 0.471. 0.471 or 2, I think I got 2, but anyway, kg per second. Okay, H1, can you tell me H1? H1 is 2749, very nice. H1 is 2749. So this is also known. How can you find out H2? How can you find out H2? How can you find out? Can I calculate H2? Sachin, yes, 0.472. I think I am getting the same. Okay. Can you tell me what is H2? Very quickly. H2, can you calculate? Here is it H2. H2 is this side. And I hope you all know it is HF plus X HFZ. Very nice. Very nice, Bhavya. So can you tell me H2 as well? Then the question is solved. Nothing is there. The value of H2. Sachin, is it clear how I... so here you write HF plus X Hg minus HF. Okay. But it is at what? Exit. So 4.5 bar. So you will see this, and this is your Hg, this is your HF, and X is equals to 0.95. So can you tell me how much is H2? H2 is no, it is not correct. Are you not able to see the values, Bhavya? If I mean, is it blur or something? Pawan, did you ask something? Is there an issue? I can explain. 2637, yes, that is correct. 2637, okay. H2 is 2637. 2637 kilojoule per kg. Now, can someone very quickly, okay, so now the conclusion of this is that I know H2 as well, but still I have this unknown, I have this unknown, and I have this unknown, two unknowns. So I cannot use this equation. Everything else is known to me, but I have two unknowns, so I cannot use this equation. So what will I do? I need to calculate exit velocity. Exit velocity, and it is a steady flow system. In a steady flow system, SFE is valid, and also continuity equation is valid. Continuity equation is valid. What is continuity equation? Mass conservation equation. Mass conservation equation. Okay. So m dot in is equals to m dot out. A1 V1 upon specific volume 1 is equals to A2 V2 upon specific volume 2. Sachin, are you gone? Why are you not answering? You're not doing, I mean, are you not calculating? How much the HF? Okay, HF is 623.5 kilojoule per kg. This is HF. Hg is 2744 kilojoule per kg. Okay. HF is 623.5. Yes. Okay. Now, it is a horizontal pipe. So area 1 is equals to area 2 on both the sections at inlet and exit. Area is same. I have to calculate V2, velocity at 2. So V2 is equals to V1 into specific volume 2 upon specific volume 1. Can you calculate specific volume 2? Same what we did with H2, right? Specific volume 2. How do you calculate it? Specific volume 2 at exit, pressure is 4.5. Can you give me specific volume value? How much have you calculated? Vf plus X Vg minus Vf. Okay. Can you very quickly give me the V specific volume at point 2? How much is it? V2 is 10.49. That is correct. Can you give me H2 is equals to 2744 No, it's not correct. I don't know what mistake you are doing. Bhavya wrote it there. It's 2637.9. That is correct. There is some mistake with your calculations. That is Hg. No, that is not H2. That is Hg. This is saturated steam. That is saturated liquid. So H2 will be HF plus X Hg minus HF. Specific volume is 0.3933. That is correct. 0.3933, and I can put this here. V2 is equals to, V1 was 10 meter per second. Specific volume 2 is 0.3933 meter cube per kg, and V1 is 0.3749 meter cube per kg. This will get cancelled. You will get 10.49. Sachin, are you able to figure out what is the problem with H2? Is it clear? H2 you can calculate by that. V2 is equals to 10.49, right? 49, isn't it? Yeah, meter per second. So V2 we have calculated. Velocity, exit velocity we have calculated. Okay. And finally we have to calculate rate of heat transfer from pipe in kilowatt. Okay, Sachin. So I have to calculate. So now what do I have? Now I know V2. Now this is also known. So in this equation only one unknown. Okay. In this equation only one unknown. I can use this equation and calculate Q in. So can you tell me what is Q in, or do I need to solve it for you? M dot in H in plus V in square. Now because H you are putting in kilojoule per kg, right? So you have to write 2000 plus Q dot in is equals to M dot out H out plus V out square by 2000. Everything I know. I need to find out Q in. Q in minus 52.29. Yes, that is correct. Minus 52.29. Okay. Kilojoule per second. Because it is dot. Okay. So it is kilowatt. Okay. So this is negative. What does it mean? This is not Q in, but this is Q out is equals to 552.29 kilowatt. Okay. I hope this is clear, because very quickly we have to move to unsteady flow systems. Okay. Could you please tell me if it is clear? Sachin, is it clear? Bhavya? Okay. So very quickly, let's move on to, okay, this is a question for steady flow. I leave it for you. You try this. If I get time today, I don't think I will get time today. If I get, we will discuss this, but you maybe take a screenshot or something. Okay. Try to solve this. Steady state, steady flow system. Then we will move ahead with unsteady state. We have 20-25 more minutes. Okay, let's move on. Unsteady state system. So I hope you are aware with unsteady flow systems. What do we have? Let's say we have a system here. We have a system here. Now some mass is coming in. Mass is coming in. So when this mass is coming in, it is bringing some energy with it. Okay. Yes, you can try, Bhavya and Sachin and everyone, please try this. Okay. So when this mass is coming in, it is bringing some energy. Anyway, first of all, let's apply energy conservation equation, which is energy in is equals to energy out plus energy of change in energy of the system. Change in energy of system. Now this change in energy for system was 0 for steady flow, but for unsteady flow it is not 0. Also, what is not 0? M in is not equal to M out. M in is equals to M out plus change in mass of system. Change in mass of system So in unsteady state, what happens? Either the level of the amount of mass in the system will increase or decrease depending upon how much mass is coming in and how much mass is going out. Okay, M out. So when this mass is coming in, it is bringing some energy with it. What is that energy? That is M in H in plus V in 2 plus GZ. Okay. Also, I am assuming I am giving some heat to it, Q in. I am assuming, I don't know. It can be rejected to the surrounding, but I am assuming I am giving. So I will take it in the inside of it. Okay, Q dot Q in. Okay. Now what is going out? So when this mass is going out, it is taking some energy with it. What energy it is taking out? M out is equals to H out plus V naught out plus GZ out. This energy it is taking. Also, I am assuming my system is there and it is giving you some work output. So I have to write it on the outside, right? On the outside, work output. Now, very important thing here is that M in is not equal to M out. So what will happen? For example, here, if mass is M1, so it will not remain constant as M1, because, for example, if more mass is coming in, then the level will decrease to M2, which is greater than M1. Or if more mass is going out, then the level of mass will decrease, so M2 will be less than M1. Okay. So if I say the initial condition of this system is 1 and the final condition is 2 of the system. So when the mass level is increasing or decreasing, the energy of system is changing. The energy of system is changing. So what is the change? So what is this energy change? This is plus M2 U2 plus V2 square by 2 plus GZ2 minus M1 U1 plus V1 square by 2 plus Z1. This is the change in the energy of the system, inside the system. Okay, is it clear? Can you quickly tell me, is it clear? This is because what is entering, this energy is what is entering. This is if we are giving some heat. This is because the mass is leaving, so energy leaving, if work output, and that is change in energy of the system. Okay. Okay, Sachin, if it is clear, then your questions, your unsteady state questions will look very big. But if you understood this, you have to know what are the terms that I can cancel. Now, again, most of the times you have to calculate kinetic and potential energy everywhere most of the time. If they are giving you some information about velocity in the question, then you cannot cancel, otherwise you can cancel that. Okay, also everything will get cancelled. Also its application, unsteady state applications are filling of tank, filling of bucket or filling of tank, whatever it is. So what is happening? I am filling a tank. I am filling a tank. No mass is going out. If no mass is going out, then this can be 0. This can be 0. If no mass is going out, then this can be 0. If the tank is initially empty when I started filling it up, if it was initially empty, then this will be 0. Okay, so based on what is given in question, you can cancel a lot of things. Also second, emptying of tank, emptying of tank. So your tank is already filled, it's full, right? So you know what is M1, you know what is M1. You are emptying it completely, so M2 will be 0. In the end, how much mass will be there in the system? 0, because you have emptied it completely. And your tank was full, nothing is coming in, so this will be 0. Only M out will be there. So based on what is given in question, you can cancel a lot of terms in this equation. This equation looks really big, but ultimately you don't have to solve everything. Okay, this will get very simplified once you read the question and you are able to cancel the terms that are not required. Okay, very quickly let's move on to the question. A rigid tank whose volume is 0.75 meter cube. We have a rigid tank, volume is 0.75 meter cube, developed a small hole in its wall. Air from the surrounding at 1 bar. So air is coming in. Air is coming in at pressure P in 1 bar and temperature T in is equals to 25 degrees Celsius. Leaked in, and finally the pressure in the tank reached 1 bar. So final pressure, what is final pressure? P2. Final state is 2, not 1 is the initial state, P is 2 is the final state. So P2 is equals to 1 bar. The process occurred slowly so that the heat transfer between the tank and the surrounding kept the temperature of the air inside the tank constant. Okay, so inside the tank temperature remains constant. T1 is equals to T2 is equals to 25 degrees Celsius. 25 degrees Celsius. Or determine the heat transfer involved in the process. You have to determine the heat transfer involved in the process. How much heat transfer is happening? Q, let's say I am giving it heat. I am giving it heat. Let's say whatever it is, it does not matter. Okay. Now the point is, we have equation, right? Now first of all, nothing is given about kinetic energy and potential energy. We can cancel that. In this equation, nothing is given in the question. Nothing is given about kinetic energy and potential energy. I can directly cancel that. Okay. What else? What else I can do? Now you see, initially it was empty. Initially it was empty. Okay. Initially it was empty. So initial mass M1 is equals to 0. Initially it was empty. Okay. Now, what is anything going out? Is anything going out? M out. Nothing is going out. So M out is equals to 0. M out is equals to 0. Now it is a tank. It is a tank. Only filling process is going up. So work, no work is involved. No work is involved. So what can I conclude from this equation? Look, this everything is 0 because m out is 0, so everything is 0. This is 0, this is 0. Initial mass is 0, so this is also 0. This is also 0. Okay. I am neglecting kinetic and potential energy. No information in the question. So this is here, this is not 0. Okay. M2 is not 0. But I can neglect this. So ultimately what do I have? I have M in, what is coming in, and HI plus Q in, and everything else is 0, and M2 U2. Is it clear? Very quickly tell me, is it clear? What is left is M dot in. Okay, we are doing A part. Okay, so they are saying initially the tank was evacuated. So M1 was 0 earlier. That is why that is how it came. Okay, initially the tank was empty. Okay, so I am left with M in, H in plus Q in is equals to M2 U2. Is it clear? This portion, this portion, and this portion. Could you please tell me this is clear? Is this how this equation came? Is this clear? Then we will move ahead. Very quickly, please tell me. Our time is, we don't have much time. Yes, okay, Pavan, if it is clear, then very quickly tell me what is Q in. Q in is equals to M2 U2 minus M in HI. Now you see, initially the tank was empty. Now I am filling the tank. So whatever M in is there is whatever is filling will be equal to the final mass, because the tank was already empty. Okay, it was empty in the beginning. Okay, so I can write M U2 is CV T2 minus CP T in, and also tell me, they are saying that the temperature is remain constant. So Ti is also 25 and T1 is equals to T2 is 25. So I can take T CV minus CP, CV minus CP. Very quickly tell me, what is this? CP minus CV is equals to R, and this is air. This is air, okay? Air from the surrounding. Last, I think yesterday it was the question that ideal gas, that in that question it was missing. Okay, you cannot use, if ideal gas is given, it was, maybe it was my mistake, I did not see that question properly. If it is ideal gas, you cannot use air. Air should be specifically given, only then you can use R and CP values. Okay, CP is equals to 1.005 for air, and R is 0.287 kilojoule kg Kelvin. Kilojoule per kg. Okay, so tell me what is the answer? What is the answer? Did you solve it? Okay. What is Q in? R is, yes, 0.287. Yes, correct. Are you able to calculate mass also? I need mass, right? Mass is equals to, how will you calculate mass? How will you calculate mass? P2 V2 upon R T2. P2 is known, volume is fixed. T2 is also known, R is 0.287. Okay. So 75. But is it positive or negative? Yes, because this is minus R. This is minus R, okay? How much is mass? How much mass is there? Mass is equals to yes, that will be kilojoule. Yes, kilowatt was not correct. Okay, 0.877. Yes, 0.877 kg. Okay, and when you use this, temperature is 298, 25 degrees Celsius, and minus R is minus 0.287, and the answer is minus 75 kilojoule. So minus means I am assuming it is in, but in the system it is going out. Okay, Pawan, is it clear? Are you able to follow this? Please quickly tell me, and I have to solve the second part of it. I don't think we will be able to move ahead. Okay, then we will move ahead. I hope you got this. Okay, Q in. Now next part is if, okay, this we have solved already. Next part, if it is contained air at 0.7 bar and 25 degrees Celsius. So this time your tank is not empty. Your tank is not empty. It contains some mass M1 at pressure 0.7 bar and T1 25 degrees Celsius. Then when the mass is flowing M in, it will change to M2. It will change to M2. Okay. So M2 we already know. We already know that the final pressure is P2 is equals to 1 bar. Final pressure is 1 bar. And temperature T2 is 25 degrees Celsius. So M2 will remain same. We already calculated M2 like this, right? M2 is equals to P2 V2 RT2. This is what we used. And volume is constant. It is a rigid tank. Okay. You can calculate M1 as well. P1 we know. V1 is same. Volume of the tank is constant. So V1 is equals to V2 R, and T1 is also same. T1 is equals to T2. So M1 you have calculated as .614. That is correct. 0.614 kg. Okay. Now you see, now this time exit is still not there, so this will still not be there. Again, this is not there, but this time this is not 0. This time it is not 0. Okay, so you have this, you have this, you have this, you have this, and you have this. Okay, so we will write this very quickly. Sachin, what happened? What did you do wrong? Okay, what do we have? M in, H in plus Q in is equals to M2 U2 minus M1 U1. M1 U1. M2 I know, M1 I know. What is M in? Can you tell me what is M in? Can you tell me how can I calculate M in? Can you tell me very quickly how can I calculate M in? M2 minus M1. Very right. Very nice. because already M1 was there. Okay, now the final mass is M2. So how much came? The difference between M1 and M2. Okay, Min is equals to M2 minus M1, which you have calculated to be 0.263. I think that is absolutely correct. 0.263, yes. Now there is nothing left. There is nothing left in this question, right? Can you very quickly tell me what is Q in? Sachin, can you please solve it and tell me how much is Q in this case? Pavan, are you there? Where did all the people go? Pavan was there. Who else was there? How much is Q in this case? What? No, sir. I mean, I didn't understand. What did I ask? I forgot. Okay, are you you're not solving it? I don't think that is correct. Can you try that again one more time? Minus 134, I don't think that is correct. Okay, M2 is how much? 0.877, okay. 0.877, and U2 is CV, 0.718. T2 is 25, means 298 Kelvin. Okay. Plus, I'm sorry, minus M1 is 0.614, 0.718 into 298. Temperature is constant. Now this will go this side, minus 0.263 Cp H. In this we have Cp, right? You are, I think, some problem with units, I guess. Answer seems okay, or maybe I have done a mistake. I don't know. Please calculate it. I just have answers. Okay. 0.263 into 1.005 into 298. I think it's 20. Yes, that is correct. Minus 22.504. I was confused if I did a mistake. Okay. What was the mistake earlier? How did you get minus 225? Okay, so minus 22.5 kilojoule. Okay. So Sachin, are you there? Have you solved it? It's okay, you can take your time. If there is an issue, you can tell me tomorrow. Okay, no issues, Bhavya. It's fine. Okay. So I have one more question I was thinking of solving today, but you take this question. These are good questions, okay? You take this question, try to solve this. If there is an issue, we can discuss this tomorrow. It could be little not complicated, little bit difficult, but if you apply the concept that I have told you here, you write the whole equation, you see what is there, what is not, and you try to solve it. Okay? Just take this question, because we are already after 7. Okay? Sachin, maybe a little bit mistake you are doing. It's close, it's very close, but I think some values you have, maybe some round figure you have taken. So there is a discrepancy in the question, in the answer. Okay. So I hope you have taken down this question, okay, and this question and that question. This question, okay. Please try this tomorrow. Give me the answers for this. Sachin, Please try, Pavan, please try this. And okay, so I'll see you tomorrow, guys, at the same time, 6 p.m. Okay, and what we will start tomorrow? We'll start second law, questions on second law. Okay, this is what we are going to start. Thank you very much.